Okay, here's the continuation of graphing other trig functions, part two. We're going to take a look at tangent and cotangent. So I'm going to do what I did before and take a look at the unit circle. So I'm going to take a look at the unit circle and we're going to take a look at the behavior of tangent and then try to figure out like what section we're actually going to be looking for. And again, it's the whole idea of repetition and yeah, just like we did with sine and cosine. So if I color code tangent values as orange, if I'm in the first quadrant here, then I know my tangent values are positive. If I go up to the very top point here at pi over 2, well, that point is 0, 1. Remember that tangent is sine over cosine, which means up here, tangent is going to be undefined. Okay, come over here, tangent's going to be negative. Okay, over here on this end, we're going to get that tangent is 0. Okay, and then down here, positive. And then we're back at undefined again. And then in this quadrant, we're at negative. And then here, we're at 0. Okay, so I do see some repetition. If I take a look at this, if I go from 0 radians, it looks like I'm starting at a value of 0 for tangent, going through positive, hitting undefined, hitting negative, and then hitting 0 again. So 0, positive, undefined, negative, 0. Okay, 0, positive, undefined, negative, 0 again. Okay, so the yellow and the blue match. The problem is that if I have an undefined in the middle, then I'm going to have a vertical asymptote in the middle of this thing, and it's going to look like two pieces of something. So I'm going to propose that we take a look at another pattern. Let's say instead of going from 0 to 0, we go from undefined to undefined. Okay, so let's take a look again. So let's go undefined at the top, through negative, so undefined, negative, 0, positive, undefined. So undefined, negative, I'm going to follow the order and see if this will do it. Undefined, negative, 0, positive, undefined. Okay, those match. So I've got 0 in the middle of it, that's good. And then I've got vertical asymptotes on the end of it. That's good also. So if I take a look at this, the left half of the circle, yellow, matches the same pattern as the right half, which was blue. And the question is which part do we want to use? Well, we really like to stay as close to the origin as possible. So like, I really like 0, 0 involved if I can do it. So if you think about the sine graph, 0, 0 was where we started. Cosine, it was 0, 1 where we started, just because cosine of 0 is 1. So I'd really like the blue portion of the graph to be involved if at all possible. So we're going to stick on this side here. Now the next question is that if 0 is here, this can't be like, the bottom can't be 3 pi over 2. That doesn't make any sense. Because if you're at 3 pi over 2 down here at the bottom, and then you're at 0, and then you're at, like, that doesn't make any sense. This would be pi over 2. So that doesn't follow. However, if I make one change, let's change my 3 pi over 2 on the bottom to negative pi over 2. If this is negative pi over 2, negative pi over 2, 0 pi over 2, I think we're good. So now if we take a look at our table, hopefully now you can see my rationale of why I chose these points. I want the asymptotes on the ends. I don't want an asymptote in the middle of it. I really want 0, 0 involved if I could get it. Like to hover around the origin if at all possible. So if we went through and we graphed it, and I've already talked about this a little bit in class, tangent looks like, it's not, but it looks like just a whole bunch of little cubics. Kind of one right after the other, right after the other, right after the other. One of the things to keep in mind, though, big difference between the previous graphs, the other 4, and this one specifically, and cotangent as well, is that, yeah, you do have the phase shift business, but what we're really focusing on is that 0, 0 is like the first original point. The period, which is pi this time, because negative pi over 2 to pi over 2 is pi, it's actually a total distance of pi. So it's left pi over 2 from 0, and then right pi over 2. Previously, we've been graphing like the first point and then continuing our graph to the right. That's not the case this time. You plot the middle point and then go half of the period to the left and half of the period to the right. There's a slight difference in this one than in any of the other ones. Okay, I know this looks a little intense. I realize that. But to get the cotangent graph, we're going to do the exact same thing that we did to get cosecant and secant. Take the original graph. So if you want cotangent, graph tangent lightly, and then any points that are located on the midline, when you find the reciprocal of them, it's going to turn into undefined. But keep in mind that anything that's undefined is going to turn into 0. So just as a reminder, if you have an undefined value and you do 1 over undefined, this is 0. If you have 0 and you do 1 over 0, this is undefined. So just be careful. And yeah, this looks intense. I realize that. Quick note though, there's no amplitude on this one. I think that's obvious. The other thing that's really fantastic about tangent and cotangent is there's no relative max or min, like at all, because they keep going forever. Because of that, the range on these is always all real numbers. It's pretty fantastic. Okay, let's take a look at our very first one and see what we can do. Now, you can take the table of points, which I think I'm going to do for the first one, and then for cotangent, you can use what you know about graphing tangent with or without a table, and then use your tangent graph to rip and flip. Number one recommendation, though, whenever you are graphing tangent or cotangent, especially cotangent, consider graphing a couple periods. It makes it look a little bit easier. I know it seems like more work, but it'll pay off in the end. Otherwise, it looks like you're just not done, and you might be a little confused by that. Okay, so y equals tan x minus pi plus 1. Let's start answering some stuff here. Let's see. Amplitude, none. Period this time. Well, the period of tangent is pi, because it's negative pi over 2 to pi over 2. But it's still going to be pi divided by b. So pi divided by b in this case, well, b is just 1, so pi. Phase shift is the exact same thing it's been before. So it looks like right pi, so it's right pi. Vertical shift is up 1, so it's up 1. Domain, I have not any idea. I have to figure out where the asymptotes are first. Range, though, range is all real numbers. I already know that. And then yes, I do. Relative max and relative min, none. For sure. At no point in time is a tangent or cotangent graph going to have relative extrema, like at all. So now let's actually start with a table of values here. So for our y equals tan x, so just our regular parent here. Remember, we're going to go from negative pi over 2 to pi over 2. So let's go negative pi over 2. And then we will do, I'm going to do pi over 4s, which is actually kind of nice because pi over 4s for tangent is 1 or negative 1. So let's do negative pi over 4 because I just want to get some points in between. 0, pi over 4, and then pi over 2. So if you're looking for like the parent points of tangent, these are the ones that we're always going to do. Okay, so tangent of negative pi over 2, well, that's at the very bottom. This guy's undefined. Tangent of negative pi over 4 is tangent in the fourth quadrant. That's -1. Tangent of 0 is 0. Tangent of pi over 4, that's first quadrant tangent. That's 1. And then tangent of pi over 2 is undefined. Okay, now let's take a look at what we got to do here. So my x value is going to get divided by 1. And then I'm going to add pi to it. Then I'm going to take my y's and I am going to times them by 2 and then plus 1. So 2y plus 1. Okay, let's go ahead and fill this in. So this is going to be negative pi over 2 plus pi, negative pi over 4 plus pi. I'm going to do the exact same thing that I did before when I did a table. I'm going to go through and make sure that the denominators all match, and I'm going to use those as the increments. Pi over 4 plus pi, and then pi over 2 plus pi. Okay, if I take a look at these, I've got denominators of 1, 2, and 4, so I'm going to go 4. So I've got negative 2 pi over 4 plus 4 pi over 4 is 2 pi over 4. Then I've got negative pi over 4 plus 4 pi over 4 is 3 pi over 4. I've got 0 plus 4 pi over 4 is 4 pi over 4. Take a look. We're all going pi over 4 distance. This next one better be 5 pi over 4. 4 pi over 4 plus pi is 5 pi over 4. And this better be 6 pi over 4. So it's going to be 2 pi over 4 plus 4 pi over 4, which is 6 pi over 4. Okay, that's good. Remember, all of those need to have a consistent distance between them. Okay, then times 2 plus 1. All right. If you take something that is undefined, so 1 over 0, and you times it by 2, it's now 2 over 0. It's still undefined. If you then take something that was undefined and you shift it up 1, it's still undefined. That hasn't changed. That's still undefined. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. 2 times 1 plus 1 is 3. And then undefined. Still undefined. That hasn't changed. Okay, so let's go ahead and see if we can plot these on our graph. Okay, so I have my vertical shift of 1, which means I've got my midline at 1. And I'm a big fan of that being the first thing on my graph before I even put the increments on the x-axis. Okay, then I'm going to start at 2 pi over 4 and go to 6 pi over 4. Maybe I just do 1 box equals 1 pi over 4. So there's 1 pi over 4. I'm not going to label it though because I'm not using it. 2 pi over 4. There's 3, 4, 5, 6 pi over 4. Okay. All right, here we go. 2 pi over 4 is undefined. Vertical asymptote. The next pi over 4, which is 3 pi over 4, is now at negative 1. Let's go ahead and mark that increment there. So it's negative 1, and then I'm going to need 3 also. Okay, so I'm here at negative 1. Then at my next pi over 4 over, I'm on the midline. So it should be the middle of my tangent graph. I almost called it cubic, my tangent graph. Then the next one over is up at 3. And then the next one is my vertical asymptote again. Sketch it just like you would a cubic. It's not one, but it certainly looks like it. That is one full period of tangent. Now, since I'm not doing cotangent, I'm actually okay with just one period. It's cotangent that I think I need 2 or 3 or however many. Okay, let's see. I know where my vertical asymptotes are, so I've got one at 2 pi over 4. So let's go x equals 2 pi over 4 plus or minus. Okay, the next one was at 6 pi over 4, which is at the full period away. So this is my full period length. So quick note here, that is the period. Not half of it, it's the whole thing. Okay, so now we can do domain. So let's do all real numbers. X not equal to negative 2 pi over 4. You could simplify it if you want to, pi n, but you don't have to. Let's see, what else do we have? No max, no min. Y-intercept, even, odd, neither. Okay, maybe I will graph some more of this. Okay, so I'm just going to copy paste this thing over. So one box over, I would have another point there. One box over, I'd have another point there. One box over, I'd have another point there. One box over, I'd have another vertical asymptote. So this is the second period. And I don't need this. I'm just trying to help myself out. If I fold it on top of the y-axis, this thing is definitely not even. If I try to go through the origin, remember, origin is where you need to look at. So my red dot, this thing is not odd either. This thing's neither. And then let's see, y-intercept. Did I actually come up? Oh, I did. I got a good one. Okay, 0, 1. Okay, so there's my tangent graph. Not too bad. It gets a little crazy looking, but it's not too bad. Okay, the next one's cotangent. So here's what I want you to do. I want you to pause the video. I want you to rewrite this as tangent. Remember to factor out the coefficient there. You need to do that. And I want you to graph just tangent. See if you can do it using the table. And then we'll rip and flip and see what we can come up with. So pause it. See if you can graph the tangent graph. Okay, so here's where I'm at so far. I went through and I pulled out the half off the coefficient of, pulled the coefficient of half off of the x. And then I created my parent points, negative pi over 2 to positive pi over 2. And then remember, it's always the opposite of what you think is happening or what you see is happening with the x's. So it looks like I'm timesing by a half, which means I'm dividing by a half, which is the same as times by 2. And then I'm minusing 2 pi. And then my y, I'm just going to subtract 1 from it. So I went through and I saw the denominator of 2, so I just turned them all into a denominator of 2. Figured that would make my life a little bit easier. Okay, so let's go ahead and give this thing a quick sketch. All right, so I need to go down to negative 2. All right, let's do a couple boxes. So let's do negative 1 is there, negative 2 is there. And remember, you choose your increments. I am choosing to use 2 boxes. You don't have to. Let's see, it was supposed to be at negative 1, so that means that my midline is now at negative. Oh, that's not correct. Let's move that guy. Oh, no, it is at negative 1. Why did I mark negative 3? I don't know why I marked negative 3. Just confused myself. Okay, so midline is at negative 1. All right, let's get our graph on here. Let's see, negative 6 pi over 2 and negative 2 pi over 2. I don't know, I think I'll use one box for a pi over 2. So there's negative pi over 2. So that's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. All right, now I've got those guys. Negative 6 pi over 2 is undefined. Vertical asymptote. I'm doing this in gray because tangent is not the answer to this. Negative pi over 2, have another vertical asymptote. And then at negative 5 pi over 2, so right next to negative 6 pi over 2, I'm down at negative 2. And then at negative 4 pi over 2, I'm on the midline at negative 1. Oh, I just noticed that this guy is in the wrong spot. Let's move him over. I don't need negative pi over 2. I need negative 2 pi over 2. And I noticed that only because it didn't look like my points were the same distance apart as I was plotting them. And I checked my table, and I was correct. They were not the same distance apart. Okay, and then I'm at negative 3 pi over 2, and that puts me at 0. Okay, there is my cubic. Again, not my cubic. Looks like it, but it's not. It's my tangent graph. Okay, I'm going to go through, and I'm going to do another one of these. So if I count across here, it looks like it's 1, 2, 3, 4 boxes until I get to the next vertical asymptote. So I'm just going to count over. 1, 2, 3, 4. So that is where I want my next one to be. So let's get rid of this orange. And I'm just going to copy what I see. So in the middle. and then left, and then right. So just copy paste. That's it. Okay, now I've got two tangent curves. Now I feel better about actually going through and doing my cotangent. Okay, cotangent. It's color-coded in blue. Amplitude, none. Period. Well, the period is going to still be pi over b. It's going to be pi over a half, which means this is going to be 2 pi. Phase shift, it's going to be the exact same phase shift as the tangent, so left 2 pi. Vertical shift, the exact same vertical shift as the tangent, down 1. Domain, don't really know. Range, all real numbers. Y-intercept, not sure. Even odd, neither, not sure. Relative max, none. Relative min, none. Asymptotes, yet to be determined. Okay, so here we go. I'm going to use blue for this. Every point on the tangent curve that was on the midline, so that I just marked in blue, those 2 dots are now vertical asymptotes. So this is my rip. The points in between my 2 vertical asymptotes, those 2 gray points on the tangent curve, when you find the reciprocal of them for cotangent, is the exact same value. They don't move. It's kind of fantastic. The vertical asymptote, so the gray vertical asymptote between those 2 blue dots, is now going to get its reciprocal. What was undefined is now 0. So if I connect those, that is cotangent. Now, if I didn't have a couple periods of this tangent curve, it would just look like I have pieces of it. So if I take a look at the left-hand side, what was a vertical asymptote is now on the midline. The other gray point is still included. That's the bottom part of the cotangent curve, which looks like a cubic. If I go on this side, gray dot, what was undefined is now on the midline. This looks like the top. So it almost looks like the left and the right blue portion looks incomplete. That's what it's going to look like if you only graph one of the tangent pieces. If you graph a couple of them, you'll get the full blue thing kind of in the middle here. All right, asymptotes. Well, let's see. I've got an asymptote now at, well, -1, -2, -3, -4 pi over 2. So I've got x is equal to, and you can simplify it if you want to, but you don't have to, -4 pi over 2 plus or minus. Okay, let's see how far apart these are. So this is at -4 pi over 2. That's -4 pi over 2, -5 pi over 2, -6 pi over 2, -7 pi, -8 pi over 2. Okay, this is -8 pi over 2. From -4 pi over 2 to -8 pi over 2 is 4 pi over 2. That's 2 pi. That's the period. So just like it was before with tangent, cotangent's the same. So you're going to use the length of the period here. Okay, now that we know where the asymptotes are, we can do the domain. It's all real numbers. X not equal to whatever asymptote you chose. -4 pi over 2. You could turn it into -2 pi if you want, plus or minus 2 pi n. Y-intercept. Well, I guess I could move my graph backwards. Let's see if there is one. Okay, so 1 over, down, there. Oh, nope, I don't think there is. I think that's going to be a vertical asymptote here, which means y-intercept is none. And then even, odd, neither. This is going to be neither if we extend it on the other side. Stuff isn't going to match up.